So we're looking at our fifth and final type of series where we need to find the general expression for the sum of that series. This particular type, it just has more miscellaneous types written there, but really what we're looking at are ones that expressly need a difference method involved. This particular example, there's a couple of ways that we can do it, and I'll look at the two different ways, but I'll work only one in full. Okay, so the first thing we need to do is to let u sub r equal 1 over r plus 1 times r plus 3, so that's our rth term. And you remember we've got here our denominator is an arithmetic progression, so well really we could have classed this in the previous type, but there's just a bit of a difference here because it's from 0 to n minus 1 rather than from 1 to n. Okay, so we need to multiply it by the last factor, r plus 3, minus the first factor, r plus 1, and divide that by the difference between them, which is 3 minus 1, which is 2. Okay, and taking it further, we end up with 1 over 2 times r plus 1 minus 1 over 2 times r plus 3. Okay, that we can class as vr minus vr plus 2, where vr is equal to 1 over 2 times r plus 1. Now we are summing to n minus 1 terms, but we're starting from 0, so it's going to be not u1 but u0 plus u1 plus u2 and so on, and then finishing at un minus 1. We can now substitute because u0 will be the same as v0 minus v2 plus v1 minus v3 you can see that I've quickly put in a bunch of others here. Now you may not necessarily need to put in so many of these. I've done it simply so that you can see what needs to be cancelled, and it can be a little bit tricky to see what needs to be cancelled. So let's just have a look at the start. We can see v0, there's only one v0, so that's not going to cancel. v2, we've got a minus v2 here, and if we continue on there's a plus v2, so those can cancel. So we've got a v minus v2 there and a plus v2. So what we find is that the last v within the parentheses is going to cancel with not in the next lot but the one after, so we skip 2, okay, and cancel the next. v1 is not cancelled at all because there's nothing before it with a v1, but this minus v3 will cancel with this plus v3, so we skip 2, cancel that. The minus v4 we know will cancel because we'll skip this and it'll be on the next one over here. Same with the v5 will definitely cancel. As we go on, we get to these ones closer to the end. Vn minus 5, that will have cancelled with the one previous. Now the Vn minus 3, that cancels with this Vn minus 3. The Vn minus 4 will have cancelled with one's previous. And the Vn minus 2 cancels with this Vn minus 2 here. And this Vn minus 1 will cancel with this Vn minus 1 here. But, have a look, this Vn, there's nothing beyond it to cancel, and there was nothing previous for this Vn plus 1 to have cancelled. Or it can't cancel with anything beyond it. So what we've found is there's a little bit more, a few more terms in this particular example that have survived the cancelling. We've got V0 plus V1, and we've got minus Vn and minus Vn plus 1. So just scroll down there a little further, and now we can substitute. Okay, so our V R is 1 over 2 outside of R plus 1, so with V0 then is going to be 1 over 2 times 0 plus 1, plus our V1 is 1 over 2 outside of 1 plus 1, minus our Vn, which is 1 over 2 outside of n plus 1, minus our Vn plus 1, which is 1 over 2 outside of n plus 1 plus 1. Simplifying, this is going to be 1 over 2 plus 1 over 4 minus 1 over 2 outside of n plus 1 minus 1 over 2 outside of n plus 2. Okay, and we'll just simplify where we can. So a half plus a quarter, that's 3 quarters, 3/4, and these two here, we could leave them as they are, or we can combine them, and if we were to combine them, we would end up with 2n plus 3 over 2n plus 1 n plus 2. It'd be worthwhile you having a go at combining those two fractions to make sure that you get that result. And so that's our sum to n minus 1 terms. And what I'm going to do is just scroll down and just put in just an alternate beginning to this one as another way of doing it. What we could do is, because we know that what was given was from r equals 0 to n minus 1, 1 over r plus 1 times r plus 3. We're summing to n minus 1 terms. Now that, if we were to substitute in to get the pattern, we can see that if we substitute 0 to start with, because that's our beginning, we'd end up with 1 over 0 plus 1 is 1 times 3 plus 1 over, next one will be r equals 1, so that's 2 times 4 plus 1 over 3 times 5, and so on. And let's just put here what the rth term would be, or the very last term, because it's to n minus 1 terms, so it's n minus 1 plus 1, so that's 1 over n. And then the next one here, n minus 1 plus 3, so that's n plus 2. Okay, so that's where it finishes up. So then what we find is that we can, if we were to consider this starting at r equals 1 and ended at r equals n, then we could say that the sum to n terms, rather than the sum to n minus 1 terms, would be the sum from r equals 1, as we normally have, to n of 1 over r times r plus 2. And so we'd use that rather than what we did earlier, and you might find that a bit easier. Okay, so we would go ur equals 1 over r times r plus 2. We can see that's an arithmetic progression in the denominator, so we multiply by the last factor, which is r plus 2, minus the first factor, which is r, divided by the difference, which is 2. Okay, and so we'd go from there. Okay, I won't bother working through the rest of that, but we'd work it out the same way as we did in the previous, and it'd be worthwhile you doing that. You would get the same result.